Good morning, everyone. Welcome to Brandforsk and our webinar about the finalization of the European approach of fire performance of facades. My name is Mattias Delin. I'm the Research Director of Brandforsk, the Swedish Fire Research Foundation. And together with me here today, I have two researchers from RISE. It is Johan Andersson and Johan Sjöström. Welcome.
Thank you, Mattias.
Thank you very much. Good morning.
So, please, Johan Andersson, tell me about you.
Yes, so I'm a researcher at RISE. I work in the fire technology department. I worked with simulations, CFD, but also facades for almost 10 years now. We have had several projects on facades, and now we have this on the European approach. It's about me.
Yeah, thank you. And Johan Sjöström?
Yes, so I'm also Johan then, work together with Johan at RISE. He's a project leader of this project, whereas I've done much of the experimental work in the labs, which you will see.
You are familiar to the audience, I think. You've been in our webinars before, and so welcome.
Thank you.
Some just short information about us here at Brandforsk. We have a vision, a fire-safe and sustainable society built on knowledge. We develop and communicate knowledge, mostly research, of course, and that is to limit the negative consequences of fire in the society. We started in 1979, and we are a foundation since 2019. Everything we do is funded by supporting organizations, and the funding last year was about 650,000 euro, and the funding so far this year is about 550,000 euros. So please chip in so that we can continue our work. We use the money for research and of course research communications like webinars like this one. We also have a research school for practicing fire safety engineers in fire service, and they do research on part-time on a PhD student level, and they do that for 4 years. And we also have scholarships for students. And these are our supporting organizations so far this year. Thank you so much for your support, and I hope that more of you will become a supporting organization if you are not already one. The program today, after this short introduction, you will see a presentation of the project. It will last for about 49 minutes, and after that we will have time for questions. And please ask your questions in the Q&A, and we will try to answer as many as possible of them. And let's now go to the presentation and learn more about the project.
Welcome to this webinar on finalization of the European approach to assess the fire performance of facades. This will be presented by me, Johan Andersson, and by Johan Sjöström from RISE Research Institute of Sweden. The webinar is in this outline here, background, which I will present shortly, where we start in this project. And then I will talk a little bit about the different parts in the project. We also have a test program, which will be presented by Johan Sjöström. And then I will come back to present the experimental round robin to be performed later this year, and some other things in future work, etc. later on. So this is the basics. We start from this current situation. So each member state in the European Union has its own test method. We have the German method, DIN 4102, and we have the British method, BS 8414, and then all the other methods. And also, together with this, all member states have their own regulations. So this gives a combined safety level. In this project, it was set out to start with the DIN method and the BS method. So that was sort of the preliminaries to this project. And we were supposed to take into account all different regulations or regulatory provisions into this, so we could be able to assess all criteria needed for the member states. The initial project was for 24 months. Now it's been extended due to the pandemic, for example. It has a certain budget which is fixed. And there is a project group which is led by RISE. We have BAM Germany, Effectis France, EMI Hungary, and University of Liège, Belgium. There are also 3 subcontractors, BRE, UK, RISE Fire Research Norway, and eGolf. There is a web page where we publish most information in the project. This includes test data. We have also a YouTube channel where we publish videos of the project. Some tests we performed in our lab at RISE in Borås. So the general content of this project is summarized in these 4 points. We started off with a theoretical round robin of the assessment method as was developed in a previous project. And then we had validation exercises of the fire source, for example, of the test method, which will be presented later on by Johan. And then we will test the method by having an experimental round robin. And I will talk about that in some detail because this is rather important for the success, for a successful project. And then at the end, we have analysis and fine-tuning of the assessment method. So the theoretical round robin, this was then centered around the assessment document that we developed in a previous project that was started in 2017. We then took in all information from different countries, we summarized it, analyzed it, and we proposed 2 different paths. One was to be, say, the DIN method and BS method as is. And then we had an alternative approach where we could have all things into one method, basically. Now this method was to be developed in this project. And we had a vote between the member states, and the alternative approach was chosen. Then the assessment document was analyzed by the eGolf members to see if it's readable, understandable. We divided a number of questions into the different sections of the assessment method, and we got a lot of feedback back, and this was incorporated in the assessment document. And then the updated assessment document was then used for the testing program. So the initial testing activities. So this is a series of tests, basically on the fuel source, on the test rig. So this is to test sensitivity or variations in parameters. We are working with wood crimps, for example. We are working with living materials. So that means that we need to have specific tolerances on all parameters that could influence the test method. So this is led by BAM, and it was more or less finalized at the end of last year. So now we come to the test program. We'll talk about a few points in the test program. We know that there are a number of parameters that are important, and we have to study them separately and in combination. We have limited a number of tests, so therefore we needed to specify the tests to get as much information as possible out of these tests, so we could set up tolerances for each parameter, for example, for the fuel source, where things like secondary opening should be placed, etc. And also we need to do calibration tests and research studies with as comparison with the current national methods. This is not within this project, but this needs to be carried out somewhere and in some place. We also have certain, not within the project, but collaborations with other institutes, for example, to gather more information, to take more other aspects into account. So this is from the wood crib tests for the medium scale. So this is basically starting with the DIN method. So it's a smaller type of facade. We built a small part of the facade where you have a wood crib of approximately 30 kilos. We instrumented this part of the facade so we could compare the exposure to the facades. We could compare, for example, mass loss, etc., to quantify what tolerances do we need for the wood crib. We did the same thing. This is the corresponding thing for the BS method. So there you have a wood crib which is around 350 kilos. We just did a series of tests. 2 of them were exactly according to the BS method. We tested, for example, one parameter which I will just talk about here, which is a grating or a solid board, which is the support for the wood crib. And it turns out that the solid board is really important for the large wood crib. We had the idea to harmonize the methods, to have a grating both for the small scale or the medium scale and the large scale. It turns out the solid board is really important for the large scale because we want to have a timber crib with a good enough stability and a long burning time. So we have enough time for assessments. And then we have moved on to specify some parameters for the wood cribs, for example. So the wood density, species, geometry, specific surface, etc. And then we have measured the heat exposure to the facade. We have measured the fuel consumption, that is the mass loss rates of each crib. And we have measured heat fluxes, for example, by plate thermometers. So now we take this information from the wood cribs with these tolerances that we find and put this into our test rigs and test the method itself. So for the large scale, it was important to gather certain information, such as, for example, the effect of specific surface of the wood crib. So we saw that the number of sticks vary if you specify a specific number of kilos. So we have decision now to have a restricted height to 110 centimeters. This is one way to lower the variance of the fuel source. And we also have to accommodate for a more flexible, say, mounting of test specimen, we have changed the fuel combustion chamber slightly. So it's a bit larger than it was in the BS test. That means that we had to also test different positions of the crib. So this is a part of the information gathering for the large scale test, which Johan will talk about shortly. So this is now the proposal, what it looks like. We have kept the medium wood crib as is in the DIN method. This is due to, we see that some parameters, if they are very sensitive to variations, and even more so with a smaller wood crib. In the large wood crib, we changed wood species from pine to spruce, just because we wanted to have a harmonized method, so we had the same wood species in both methods. And as I indicated before, we changed slightly the test rigs to accommodate for this more flexible mounting of the test specimen. And the medium scale you can see to the left picture, and the large scale you see to the right picture. And you see that the combustion chamber in relation to the secondary opening. The secondary opening is of the same size in both medium and large scale. There is a slight difference in the placing, but nevertheless, this is to evaluate both cases where you have no material and where you have material that could combust and give a contribution to the fuel load. And this is also in the proposed method. We have lowered the rig slightly from the initial proposal. This saves a lot of money. This saves energy for the testing labs, but we still think this is good enough for our purposes. And here are the dimensions on the large fuel combustion chamber. It has the same, basically the same opening, but now it has a lintel in comparison to the British opening. And here you can see a comparison between the medium scale and the large scale combustion chamber, where you place sticks in alternating directions. You have a solid board for the large scale. You have a platform with grating for the medium scale. Now, this is one part which is less known. Here we have gathered information from different interested partners how to assess falling parts, because falling parts is included in some of the regulations in a few of the member states, Sweden, for example, Hungary, for example. Thus, it has to be possible to assess falling parts in the method. So we have now come to the conclusions that we need two different levels. So failure for falling parts occurs when any individual solid falling part exceed 1 kilos in mass, for example. That's the level 1, or 5 kilos is level 2. But there is also the possibility to have no performance determined. This way to assess falling parts will be evaluated in the round robin that will take place later this year. And we'll see if this works out.
All right, thank you, Johan. I will continue with some experimental results of some of the tests that we have done during the past year, and some of that is included in reports which you can find on the project website. Some of the results are not there yet, but will be in our periodic report published very soon. So as Johan just said, we had tests on how to build the wood crib, what tolerances we should have on the wood crib, etc., in order to make it not to deviate too much from the original methods, the German DIN methods and the BS 8414 in the UK. So what I'm going to show here are the tests we did on the large fire exposure, so the one resembling BS 8414, and when setting it on to the whole structure, the whole facade. So we tried to test repeatability of the test against just a full scale but completely inert wall, that is an incombustible facade. And then we wanted to test how the different parameters could affect the actual reading on the facade. So the moisture content of the crib, its density, its height and position, also the size, how much can you vary the size and what effect will that have, and also if you have an applied wind, what difference does that make? So we built the facade structure. It looks like this. It's rather big, and we built these large wood cribs. put them into the combustion chamber, and it looks like this in the very initial part of the testing. To the right, you see the instrumentation where we try to assess the thermal impact. So we have these black squares here, that's plate thermometers, trying to measure surface impact. And then we have lines, a vertical line here and two horizontal lines of thermocouples, just as they are in the British method. There are also thermocouples on the wing wall, which you see here. Here's the wing wall, and also two horizontal lines. We did 7 tests, and they all investigated different things. But the most important were 3 of them. This test 1 to 3, they were to test repeatability. So we just tried to follow the standards that we set up for the wood crib, and we did basically the same test and tried to see if we could repeat the same thing. We also tried moving the crib further to the front in the combustion chamber. We also tried to apply wind, and we tried a crib with smaller sections than we have here, than we have stated. Typical results are, if we look on the vertical thermocouples, which are just on this line above the combustion chamber, the hottest are at about 1,000 degrees. That's about 1.5 meters above the combustion chamber. When you go closer to the combustion chamber, the flames are actually a bit away from the facade, making it a bit colder. We also see horizontal results. So thermocouples sitting on this horizontal line here, well, they vary, and of course they're hottest straight above the combustion chamber, and then they're colder in the corner and colder at the edges. Typical results in terms of what the fire looks like, you see here. Test 1, 2, 3, these are the 3 reproducibility tests. They all look more or less the same, although these are snapshots, it's always difficult to tell. In this test 4, we had the whole crib moved forward, which resulted in a little higher flame, even though not clearly represented here. In test 5, we had wind, and that you can clearly see here, that the whole flame is, we have wind from the left to the right in this figure, and you can see the flame actually tilting towards the wing wall. And then test 6 was a test with smaller wood crib. Looked pretty much like the other ones. In terms of repeatability, the wood cribs burn almost exactly the same. You see the mass decrease in these 3 tests here. They're very parallel. The mass loss rate, it's about 200 grams per second. The flame heights, fairly similar in all these tests. And this is a graph where we try to summarize the test. So this is following the vertical line above the combustion chamber. So here's height above the combustion chamber. And on the x-axis, you see the average temperatures that we record in a stable period during the test. So above the combustion chamber, it gets a bit colder if you're 0.5 meter above the combustion chamber, and then the temperature increases, and it's maximum at about 1.5 meters, and then it decreases as you go along the height of the facade. So this is the type of spread that we see using the wood cribs. We also did test, as I mentioned, with wind exposure. This is a bit tricky to have a homogeneous wind since you have a big facade in the way. So wind is, of course, never homogeneous. It will change when it comes closer to the facade. So we measured wind in 3 different positions. We have a apply the wind with fans, several fans in the burn hole. So, and about a meter from the main wall, so this is the main wall, this is the wing wall, and in two positions here, 1 meter from the main wall, we have about 2.5 meters per second if you're a meter above the combustion chamber, and then it decreases with height to maybe 1.5 meters. When you go closer to the surface, the speed, of course, is hindered. So then we're between 0.5 and 1 meter per second. And the impact this had. So test 5 is this test with wind. Test 3 is one of the repeatability tests. And the impact on flame height is clear. You can see a meter difference in how high the flames reached. And also this graph again, where you can see the temperatures on the x-axis and the height on the y-axis. You can see that this test 5, is a lot lower than the others. So this wind made a huge difference in the exposure to the facade, even though the crib itself burnt equally fast. We can compare this to tests that were done at Effectis France, where they did the same test outdoors. And so here are some results on this horizontal line above the combustion chamber at different distances from the corner. And you can see that they're all a lot lower than the results that we had when we did test indoors without any applied wind. So clearly, even small wind conditions do have a large impact on the exposure to the facade. Okay, so conclusions from these tests is that moisture content actually made not so much difference. So if you change the moisture content by plus or minus 1% or 1.5%, so unit percent, then it doesn't make much difference. It only delays when the test starts. The section size also make very little difference on the exposure to the facade, although it does make a difference to how fast the crib collapses, which can be cumbersome, of course. We noticed that a fixed height of the cribs seems to be more important in order to reproduce the test rather than a fixed mass. So even if you have higher density, you don't need to have a lower crib. So a fixed height seems to be more important. We should suggest this to be 110 centimeter high. The combustion chamber depth didn't matter that much. We decided to push our crib a bit further in, so any collapse of it and so on wouldn't affect the test as much. Wind is very sensitive. We need a criterion for that. And falling parts can always, if they are combustible, ignite when landing in front of the crib. And there is no way to come around that. All right. So we also did some extra tests where we tried an alternative heat source. So many aspects of using these very large wood cribs are cumbersome. There are variations, of course, and they collapse at some point, meaning that, as you see here, that there's lots of charcoal in front of the facade, which might influence and definitely influence any measurement that you could have on falling parts, which will land exactly here. They're also very costly. It takes time to build them. You need to cut them, you need to control the density, the moisture content, you need to condition them for an extended period in order to reach the moisture content that we want to have. You have to build them and nail them, and then you put them in this combustion chamber, which also is very large in order to accommodate this big fuel pack. So what we tried to do was see if we can get the same exposure to the facade with a gas burner. So that's a propane, non-premixed propane burner, where you put propane into a metal tray like this, which is filled with gravel and sand. So the propane goes in here and it spreads in here, and then you have a diffusion flame up here. So this photo is, we reduce the combustion chamber significantly. So this is only 1 meter high combustion chamber, and the opening is 80 centimeter. Then we actually made it even smaller to a 80 centimeter high chamber with a 60 centimeter opening. And then we tried some different mass fluxes in order to see the effect on the facade wall. So we had similar instrumentation like we did with the wood crib tests. And these are some snapshots from the tests. The frame is fairly similar. It's a bit more sooty. Otherwise, it is fairly similar. I also have a little video here where you can see the flames, quite similar to the results from wood cribs. As you can all, those are all available on our project website. Okay, so if you compare the actual readings on the facade, so if we look on the thermocouples, which are straight above the combustion chamber at different heights, 0.5 meter above the combustion chamber, the gas tests that we have so far are actually hotter than the timber tests, which are these dashed lines here. But in all the other heights, the gas tests and the dash lines of the timber test coincide very well, all the way up to 5 meters here. The plate thermometers, we see the same thing at 1 meter height. It's a bit hotter. Otherwise, 2.5 meters, 5 meters, it's really good. Even at the window, something happened with this test, but the other two tests, they fit perfectly with the timber tests. And then again, this comparison diagram where we have the height and you have the temperature here. So you can see the profile along the height of the facade. We do see that, yeah, at the lowest height, we do get a little higher impact, but otherwise along the whole facade, the impact is very similar. So we believe that there should be no problem to find a solution. Yeah, this is also, sorry, this is also 2 horizontal lines. We see it's also further from the corner, further out here. The 2 methods seem to correspond really well to each other. And actually, in the first version of the British standard, there was an annex on how to use other fuels and how to calibrate these. So then they had 3 water-cooled heat flux meters, 1 meter above the combustion chamber. And then this was the result. So you wanted something that looked like this, and you needed to keep within 45 kilowatts per square meter and 95 kilowatts per square meter during a continuous 20-minute period. So that was the criterion. The 3 tests that we have here coincide fairly well to this. We can easily do a ramp, of course, and we can easily continue this and do a ramp here. But the level seems to correspond really well. So we believe that there is a possibility to do very similar thermal impact to the facade with gas burners instead of wood cribs. The repeatability of those tests are very high because you have a mass flux regulator. You just put it to the same thing, and it will be easy to control. It can operate using a much smaller combustion chamber. It actually needs a smaller combustion chamber, which again means that we can reduce the height of the whole facade by 1.5 meters. And this will reduce costs significantly because more labs could do those tests. You don't need as much material, you don't need to build as high, you don't need as much stability. So this 1.5 meter will reduce costs a lot. And costs are important, of course, since it increases the motivation for companies to test their products. All right. Finally, I'm gonna take a few minutes to discuss the secondary openings test that we did. So as Johan said, we need to study the effect of a secondary opening. It's required from the contract. There are several states that include secondary openings. Among those, the three flags that you see here. And experience from these countries is that it's often at the openings where we find the weak place in the facade. That's usually where the facade fails. So either where something falls or where fire enters, and then you see too high temperature readings. On the other hand, the German and the British method do not include openings, using the argument that voids of a facade system would decrease exposure to the rest of the facade. So what to do? We studied this, and we were thinking how to study it, and we came up, we concluded that testing a real facade system would give results that are only applicable to that specific facade system, and that it's better to just test any homogeneous material and see what happens with and without a secondary opening. So therefore, we used an insulation material. It's C-class, so it's combustible, 35 kilos per cubic meter. So we did 3 tests, 1 without the opening, and then 2 with opening. You see here is an opening which is asymmetric compared to the combustion chamber. So it stops at the center line of the combustion chamber. And here is one where the opening is central above the combustion chamber. So what happened during this test is that during the first 5 to 10 minutes of the test, this insulation material didn't burn. So it looked like this. But after some 10 to 15 minutes, the insulation material itself started burning significantly. So we could catch both these situations with the test. So for example, along this horizontal line here, the thermocouples had these readings. So first constant up to 10 to 15 minutes, and then higher temperatures when the insulation started burning. Again, results. These are the 3 tests: no opening, asymmetric opening, and symmetric opening. And these are the thermocouples along this line above the combustion chamber. These are the plate thermometers. And what we see is that we don't see much difference, actually, with or without or wherever the opening is placed. And then the facade started to burn, combust, and contributed. Of course, not here, where there were no facade material, but also there we could see very little effect. Actually, above the openings, the hottest was when we had an opening. So no real big difference there either. If we look at the 2 horizontal arrays, so here's one horizontal array which actually goes through the openings when they were there, and then the horizontal array further up. And we can see with temperature here and then width. So this is the corner, and then we go out from the corner. So here's the corner, and we go out from the corner. And what was the temperature there? Well, very similar. So this is average temperature before the facade system combusts. Very similar. And during combustion, a little higher, of course, in the very place where the openings are. Further up, also again, very similar. What we can see is that it's a little hotter above the place where we have openings. So the blue here represents the opening in one of the cases, and then the blue one here is hotter. Whereas the red one here is the opening in another case, and the red dots here are hotter. So actually, we do see just an increased temperature due to an opening in the facade. So I think I will leave it back to you now, Johan.
Thank you, Johan. Now I will talk about the experimental round robin. So the experimental round robin is to quantify within lab and between labs variability of test results. So that is the repeatability and reproducibility of the proposed method. In order to do this, we will test same facade systems at 3 different labs. So the test rig will be built in 3 different labs. They will mount similar specimens, the same type, and they will perform the test. And then we will evaluate and see what are the differences, what are the variability between labs, within labs, and so on. Now, we need certain specimens to be able to, say, assess the different criteria that we have in our methods. So that is flame spread, both vertically and horizontally, and also fire spread within the test specimen, falling parts, as I talked about previously, but also burning debris droplets. The test program looks like this. So we have now here 5 different labs. So one lab, that is Fire Research Norway, will perform both large scale and medium scale. DRE will perform large scale tests, which is naturally, it starts from a British standard, and they are experienced in doing British standard tests. So that makes sense. RISE, Sweden, will do medium scale testing. EMI in Hungary and Effectis in France, they will do outdoor testing. And this is to assess the possibility of performing tests outside. See what tolerances do we actually need on the wind. So this is what it looks like. Just as a reminder, we have the medium scale test rig, we have the smaller crib, which is about 30 kilos, a slightly smaller specimen, 4 meters from the combustion chamber. We have a secondary opening in place. We have then the smaller combustion chamber. This is 1 by 1 meter, basically, instead of the 2 by 2 meters, basically, of the large scale. And here also we have an air inlet with a fan. This is important information. So the first system, this was, just need to remind everybody that there is no budget in the project for acquiring test specimens. This means, and I think this is the purpose, is that the industry should be involved in the project. They should supply systems. They also need to then account for the mounting that is properly done at each lab. I'm sure that we have very good technicians in our labs, but they are not, say, accustomed to mount specimens. Usually the customer-based testing is the customer coming into the lab, they do the mounting. We provide support structure that you're supposed to mount on, and we want it to be similar in this case. That is to reduce the variability of, say, mounting. We need to have it as similar as possible between the labs. So this is system 1. It's an ETIX, externally insulated with a render. It has certain EPS, white, and this system is then tested according to the DIN method. We have, or we can get the information from the test report. This is important for us to be able to calibrate our method. So we have approximately a similar level of fire safety as previously. And these are the specifications of the system. We have another system. This is a ventilated facade. This is interesting. It has only been tested with the BS method, but it has been evaluated with falling parts according to the SB Fire 105 method, which is a Swedish method. And this is really valuable because then we have some information on how this system performed according to falling parts. We know that there are some falling parts, we know what they are, and we can calibrate our method according to this. And these are the specifications: external cladding system with cassettes, solid aluminum. It has a supporting system, certain fixation, joints, etc., and rock wool insulation. Now, we only have two so far agreed upon. We are discussing with a third supplier. And now we come to the large-scale testing, which is then a larger fuel source, around 350 kilos. It has a slightly larger specimen, 5.5 meters above the combustion chamber. And we have a similar proposal when ETICS would render, but this is tested according to the BS standard. It's a different insulation. There is some different base coatings, etc., finishing, but it's an ETICS system. And also, it has been tested. We have the test report, and we can do the calibration of our method. And again, we have a similar ventilated facade. Now, this is the same picture. It might not look exactly the same, but it's a system tested according to the BS standard. It's again an external cladding system with then a ventilation gap. And we can again see how would we make the calibration. Sort of the calibration is saying that we have a fire source, we have certain criteria that gives us the safety level. We are here, we know something about how this system performs. We can modify our criteria to see that it has a similar safety level. And also proposal for a wooden facade. This is tested according to the Swedish method, at least an ad hoc testing, because it was with more heptane, so it was a longer fire, but the fire intensity is of the same order, like that. And then again, we have a system 4 here. So this is a rain screen system, ventilated facade, which has been tested according to the BS standard. We know this system very well because it has been tested. All reports are publicly available, which is really good. And it's well tested, well understood system. And it has been tested with small variations in gaps. And this would give us, say, from the project point of view, this is very good because we have open reports. There is no question what we are doing, etc. Now, last part here is, so where can this method be used? So in last year, December, we had an inquiry through eGolf because we wanted to know how many labs would be able to accommodate indoors and outdoors for this new method. We see here frequency distribution that looks like this. This means that there are 3 labs, 3 meters, there are 12 labs. And for example, up to 7.5 meters, there are 6 labs. There is only 1 lab that can test up to 13 meters. So that also gives good input. So if we can keep the facade not too high, or the method not too high, there are more labs that could accommodate for the testing. And these are spread like this. So it's a fairly good spread between the different countries in the member states. Outdoor testing, fewer labs, but also available in Asia. So the next step, we have now a number of different reports in the pipeline. There is reports on the test with secondary opening, both for medium scale and large scale. Large scale was presented by Johan. We have the report where we test with gas, and we have the updated assessment method. All these will be published quite shortly on our webpage. We are now preparing for this experimental round robin. We are discussing with the suppliers. We are coordinating between the labs and the suppliers. So this has to be in quite detailed plan, because there are people that we need to travel between the labs, organize the mounting. There are systems that need certain curing time. So this is our logistics are very important for this part. And also mentioned, there is a progress report 3 to be published at the end of May. And after the experimental round robin, we will analyze the results. We will look at the variations. We will set the assessment criteria. So this is again, set in the way that we have the fuel source. We can balance our criteria to have a similar safety level as what we had previously. And after this project, there will be a standardization process. We will present a report. We will present a lot of different results using this method. After that, then the European Commission can initiate a standardization request, for example, for a facade fire testing standard. This usually takes a couple of years. So when this standardization request is finished, then CEN takes over and will develop the standard further. And that usually also takes a number of years. And then perhaps also product standards. So we are talking about time 10 years from now, when this will be implemented fully. So thank you very much for listening.
Thank you, Johan and Johan. Very interesting to learn more about your work. Quite a lot of work, actually. We have received a number of questions, and I can say that we have a number of questions, and some of you are also sharing different kinds of statements and opinions, but we will focus on the questions and not on responding to statements or opinions, but they are registered here, of course. So welcome. Let's start up with, we have one question here about how can you assess the weight of falling parts if many parts are falling at the same time?
Yes, thank you very much for this question. This is something that we have thought about. We also have tested this in a test with, say, SB Fire at the RISE lab, where we built a platform. We had load cells to register weight changes. We had a system that had quite a lot of falling parts, falling debris. Usually smaller parts, but it was deemed according to our visual assessment and measurements that it would fail at some point. We could then measure these, we could measure the falling parts. We could see that if we had the appropriate say, averaging method, we could see that we had a similar result to what we would deem to by our usual measurements. So we think that implementing this in the round robin, testing this, would also gather more information how to do this. It's not an easy thing, but if it's a large piece falling down or two at the same time, then I would imagine if they're not burning, we can easily assess individual parts afterwards. But this has to be investigated more, obviously, I would say.
Yeah, thank you. Another question here: is there experimental evidence with the test conditions specified in the assessment method, especially with regard to the spread of the possible density ranges?
So the density ranges of the crib then, or
it isn't specified here, but let's assume that.
I imagine, yeah.
Density plays more or less the same effect like moisture content on the exposure to the facade. So if you have a denser crib, then it delays the time until we get full combustion and full exposure on the facade, and then also it extends further. So as in the British method, the actual time starts, the evaluation time starts when you reach a certain temperature criteria on the facade. So the only thing that happens is that you shift that part. So it actually made little effect. I didn't show that much of that in the presentation here, but that's shown in the report, which you can find on the website.
Okay, thank you. Another question.
Yes, also I just want
please.
to add one thing here, is that there is slightly different tolerances for the large and medium scale, and the medium scale has exactly the same tolerances as specified in the DIN method.
Okay, thank you. Is it ensured that the specified design limits are not already exceeded on a solid non-combustible wall?
Design limits, so that's talking about the criteria?
Yes, so that must be the acceptance criteria.
Now assuming this regards to the British method, because that's where this could be an issue. It is known that the British method is a very severe method. It can easily be very close to the actual temperatures just from the crib and non-combustible wall. But this has to be investigated more in the experimental round robin, how to actually set these criteria.
It's important to note that the criteria for the European method, they are not set yet until after the round robin exercise.
Yes, thank you.
Yeah, and sorry. For the following parts, we have only set criteria due to there is no knowledge. So we have to have something to work with as a starting point.
Yes, yeah, good point. And can you explain more about the definition of large scale and medium scale facade tests?
Yes, this comes from our starting point. So the background from the project is that there was a previous project started 2017 suggesting that we should start with the DIN method and the BS method, and then at that time it was defined as a medium scale method, the DIN method, and the large scale method as the BS method. So that's not much more depth into that than those definitions as specified in the contract or the invitation to tender.
Yes, okay, thank you. And Johan Sjöström, you recently had a project with us here at Brandforsk. You compared the heat flux on facades we had a CLT compartment fire, and you measure the heat fluxes and you compared it with different testing methods, and if you should compare that data to this test method, where would you say that you are?
Yes, so those were tests that were designed to be possible, so realistic in the sense that they could actually it's actually a real plume that can be formed, but
Yeah.
in the very high end of the range what you can expect. And then we saw that the very worst test there, they actually correspond quite well to both this European method and the British standard. It's most other test methods are way below that. So this is the very far end of what you can get from an external plume in a flashover fire.
Yes. Yeah, thank you. And we have some questions about how you place the wood crib in the chamber, and you said that it should be placed with a distance of 100 millimeters from the back of the chamber. And why not define the distance in the front instead?
What we have been discussing for the last year or so is that the thickness, of course, if you have a thicker facade, then your crib will be further from the outer part of the facade. Yes, that's true. But then we also consider that a thicker facade is a property of the system itself. So a thicker facade will be further from any fire source in any real compartment fire that you will have. So therefore, we want to assess that will be part of the assessment. So instead, we keep the crib in a fixed position, and if you have a fixed facade, then it will be a longer distance.
Right, makes sense. And some questions about you tried out with propane gas here and to see. And did you consider that DIN for the 102.20 already prescribes a gas burner and as an alternative to 30 kilogram of wood cribs? Have you looked into that?
Yes, yeah, we're very much aware of that. So, and since that is already a part of it, then we didn't put much emphasis now on testing that. So instead, we wanted to test this very big fire load that we have in the large scale test, in the large exposure test. So yeah, we're aware of that, and continue discussions with the Germans on how to proceed with that.
Okay, thank you. And another question on the on this propane case. Have you been studying that with outdoor test or wind influencing a gas flame, and would it make any difference, do you think?
We have not yet. No, it hasn't even been in the scope of the project as of now. We did this as an extra. No, we have not yet. If I might speculate, then the actual flame could be somewhat smaller. The actual heat release is smaller, so a possible effect of wind, external wind, could maybe be a bit larger if you have gas rather than if you have wood cribs. Then again, if you use gas, you're usually indoors because that's where people have their gas facilities. But of course, outdoor test is possible. So, but it's not known yet.
No, thank you. And of course, a question regarding environment and sustainability. Why propane? Why a fossil fuel? Why not biogas?
Biogas would probably work just as fine. Propane is just a molecule. It could be extracted from biomaterials or crude oil. Yeah, I don't oppose that.
Okay, thanks. And we have some question about this secondary opening, and you used you covered the opening with a material with it has some insulation values, and it was combustible. And I mean, what if you have been using something else that wasn't burning, or maybe not as had the same insulation values? Would it differ, do you think, results?
Yes, that's the problem with testing. What happens if you put in an opening? Well, of course, it depends on what you're testing. So in order to assess that, we would have to maybe try 5 or 6 different types of systems, and even then we wouldn't capture any type of fire seals that you might have and so on. So therefore, we tried just with a homogeneous material just to see if that has an impact. And a combustible homogeneous material would probably be a type of system where it would be beneficial to have an opening, because you have less combustible material on the facade, and there is no air gaps or anywhere where you can enter. But even in that case, we saw first very little difference, and the difference that we saw was that it was a bit worse with actually having the opening. So I think that was the easiest way of concluding that an opening could is something that will improve fire spread rather than helping the facades.
Oh, okay. Let's find some more questions here. Well, one is, or many are about gas burners. Have you received any response from the Commission about using gas burners instead of wood cribs?
Yes, we have actually. That was I brought this up with the Commission, and they said, I mean, it's not within the contract, so it's purely sponsored by us. And but they thought it could be valuable for the reasons we presented, that it could be a cheaper test method. So they saw no problems in testing this as a side project, basically. We will put this into the knowledge base of the project. And as I see it, we need to develop it further to verify that it works, but it looks promising.
Okay, very good. I'm moving on with the questions. Has it been on the table to discuss longer evaluation times, like 60 minutes instead, or is it a fixed scope so far about regarding time?
Well, so that's an interesting question. So what we are thinking now is that we do not want to extinguish the cribs. That is done in the British method. They have a very particular way of assessing the fire performance. We don't know if we will do exactly the same. We will develop the criteria. We have that in mind, how they do. We have in mind how it is done in other methods, specific temperature criteria, for example, but also this time. Now we have a wood crib burning for 20 to 30 minutes in the large scale method. We will somehow calibrate our criteria to have approximately the same safety level. That is what is important.
Right. Yes.
But it's not set yet. That's sort of the answer to. We are thinking about having longer times. Yes.
Yes, of course. Yes.
It's not set at all.
Yeah. We also received a number of questions about curtain walls and glass facades and how they behave, maybe falling apart in quite extensive amounts. Have you been considering how facades like this could react to tests like this, and is it relevant if the facade is non-combustible, for example?
Yes, this is a very good question also, because it is a very important type of facade, and it is also the intention from our steering group that this should be included in the method. So it should be possible to test all types of facades. Therefore, hopefully, we will be able to do at least one test with a curtain walling system at one lab at least. We will see how if that works out. And then falling parts might be an issue, because it's now tested with a completely different method, more similar to fire resistance testing. So we'll see how that works out. But we have that in mind. We have discussions with the providers.
Okay, thank you. I'm scrolling through the questions. There are many now, so that's very good. I have here one about temperatures, and I think maybe you can answer that. The opening of the story above the fire chamber is not significant because the temperature of the plume will be less. According to this, can you? We have more questions about temperatures along the facades. How do you think they vary? You talked a little bit about the maximum value. On what height did you find that, Johan Sjöström?
I don't really see the question, but yes, the temperature variation is such that just on top of the opening, it's low-ish. I mean, it's still really, really hot. Yeah. But then it increases as you move up to about 1.5 meters or 2 meters, because the plume is extended away from the facade in the beginning, and then it is sucked back into to the facade. And then you had some question on the secondary opening.
Yeah, and following question was because how much this temperature is decreased before it reaches the next opening.
Yes, those graphs are in the reports, and I showed them. I don't have them in my head, but it decreases with some 150 or something degrees, and when you reach the opening, and then of course it continues to decrease. It's a continuous decrease as you move then further up the plume as any diffusion plume. So it's a couple of 100 degrees less, of course, there. Yes.
But more information in the report.
Yeah, I mean, and the data is available, and the reports are available.
Oh, yeah. Completely. Another question is about not so much about the plume and the temperature, but to the it's like this: how much details are expected to be covered by the future method? Fixation elements, joint fixing, air gap sealing, etc.
The simple rule is that it should be built and mounted as close as possible as in practice.
This is something that both the industry and the testing labs have experience with today, because that's what they do in all the methods that are being used today. You build your system as close as possible to what will be mounted on a wall. Yeah. The lab will assess that that's done properly, that you haven't done anything which is you would never do outside in order to impede fire spread or anything. So this is this is the same type of it will be the same type of argumentation that you have in any fire testing, actually.
Right. Thank you. And what's the timetable for the round robin tests? Do you know this so far?
Yeah, it is expected to start late summer and be finished in the autumn, so before Christmas.
Before Christmas, okay.
Yeah.
So maybe we have a webinar late,
maybe
just before Christmas, talking about that, or maybe in the beginning of next year.
Yeah.
Yeah.
So in the beginning of next year, the project should be finished, according to the current time plan.
Excellent. Very interesting. Yeah. So, have you seen any questions that I have not brought to your attention here that you would like to pick up on?
There was a lot of questions after we started discussing, so I'm not sure. But I would like to stress that all reports and quite a lot of data is published on our webpage. So that is the go-to place, and I hope you can find it. Otherwise, contact us. We are also open to answer questions if you have later on.
Yes, of course. And we will link it, of course, from our webpage at Brandforsk. So if you found the webinar, you will probably find the links as well. And any more, if you would like to give some kind of recommendation or advice or to the audience here, what would you would like to sum up with?
It is difficult to have one method which will make all different types of industries happy. There are strong incentives for one thing and other things among different industries and among regulators in the different countries. But we're trying to do something which is as good as possible for as many as possible.
Yeah, or keeping everybody equally unhappy.
Yeah.
So to speak.
Yeah, and I think in the end, it's better to have one method that everyone can relate to instead of the situation today with many methods. So I think it's definitely
that's a big, of course, obvious benefit to have one method, and you can place your product on the market within Europe instead of testing with 12 different methods, which is quite expensive.
Yeah, it's very good. Okay, thank you very much. And I hope to see you maybe in early next year, talking about the rest of the results. And we will see that all the links to your work is also published on our website. Thank you, Johan and Johan.
Thank you.
Thank you very much for listening.
Thank you. And I will give you, the rest of you, some information about what is going on here at Brandforsk and some upcoming webinars. And of course, remind you of our funding that is so far this year about 550,000 euro, and we want to extend that. So please chip in if you can. And thank you, all of you that already do. We have more webinars coming up. First one is Friday this week. It will be in Swedish. It's about the cost of residential fires. So welcome to see that. And if you want to be updated in the easiest way, you can subscribe to our newsletter. You can register to that in the bottom of our webpage. You can also follow us in LinkedIn and etc. I would like to thank my colleagues, Francis Eurenius and Matthias Hamrin, that has been producing this webinar. And thank you, Johan and Johan, for telling us about this project. And thank you for the supporting organizations that chip in and make our work possible. And also thank you to all you that use the knowledge that we are working so hard to spread. That's really important that you do. And there will be a questionnaire sent to you. Please answer that. That's very valuable for us. And that's it. Thank you so much. Bye-bye.